Hi everyone. Thank you for joining the Circadian Diabetes Code, part of the Live Better Longer series from the American Federation for Aging Research and Prevention magazine. I'm Emily Goldman, the Senior Editor of Prevention, the Health and Wellness magazine and site, and co-host and co-creator of Pancreas Pals, a podcast by diabetics for diabetics. Personally, as a type 1 diabetic, I am incredibly excited to be speaking with today's accomplished scientist about the connection between certain types of diabetes and the circadian rhythm. The Centers for Disease Control define circadian rhythms as internally driven cycles that rise and fall during a 24-hour day and help you fall asleep at night and wake up in the morning. While we all know that sleep is important, we're going to go into a bit more detail than the importance of getting enough hours. If this is your first Live Better Longer webinar, we're so glad you could join us. And if you're a frequent attendee, welcome back. We're continuing to have interesting conversations with top experts so that we can share more than simply the latest research on health and aging, but specifics on how to make the most of your health and apply the findings to your daily life. AFAR is a leader in supporting aging research, really making sure this area of research, which affects all of us, gets the attention it deserves. And prevention has a long history of bringing advice and ideas to people across the country. Today, I'm so excited to be talking with Satchin Panda, PhD professor in the Rita and Richard Atkinson Chair in the Regulatory Biology Laboratory, Salk Institute for Biological Studies. Dr. Panda was even the 2014 AFAR Julie Martin Mid-Career Awards in Aging Research recipient. And he's literally written 2 books on today's topic, diabetes and circadian rhythm. So thanks for joining me today, Dr. Panda.
Thank you. Happy to be here.
And thanks for letting me work through that intro. So before we jump into everything, I really want to learn a little bit about your lab's work and your books, but specifically, let's start with how did you get started researching healthy aging?
Well, first of all, let's define what is being healthy. Being healthy and to be at the peak of our physical, emotional, and intellectual health, irrespective of our age, gender, or health condition, is a universal human aspiration and human right, of course, which means that being healthy is not only the absence of disease, but also to be fully functioning in every single day. And if we distill it down to what a healthy day looks like for everybody, then we can make some simple assumption that in the morning, waking up feeling fully rested and full of energy, in the midday being at our peak intellectual state, in the late afternoon being in our peak physical performance, being in the evening being in our optimum emotional state, and at night being able to fall back to restorative sleep that we all deserve is kind of a healthy day. And the cycle repeats every day. So my interest is on circadian rhythm, or how our internal timing system regulates all these processes to the right time of the day so that we can stay healthy. And that's my segue to staying healthy until our old age.
Awesome. So let's talk a little bit about your findings. And before we get into too much detail, I know I touched in my intro what the circadian rhythm is, but can you explain it a bit in your own words?
Yeah, so we can say circadian rhythms are the internal timetables that are present in every cell and even every organ in our body. So circadian rhythms constitute the master plan that guides what time of the day or night each of our 20,000 genes turn on and off, so that function of every cell is tuned for peak performance. So that means these timed activities in our body supercharge our metabolism so that we can detoxify, DNA repair, and we can improve metabolism to stay healthy. It optimizes our brain function for emotional and intellectual health. It accelerates repair function to recover from injuries and improve our immune function so that we also stay healthy in the face of infection. So circadian rhythms essentially regulate every aspect of our physiology, metabolism, and behavior in every hour of the day.
Awesome. So we'll later on get into a little bit more about the connection between lights and circadian rhythm. But for now, since we are here to talk about circadian rhythm and diabetes, and types of diabetes, I should say. I'd love if we can explain what type 2 diabetes is and the various types of diabetes your research is focused on.
Yeah, so many of us have heard the term diabetes, and diabetes is a condition where our body's internal mechanism doesn't work properly to maintain our blood glucose level within a very narrow range of between approximately 70 to 100 milligram per 100 ml of blood. So the magic number to keep in mind is 100 milligram of sugar over 100 in 100 milliliter of blood. So as a result, our blood glucose typically stays above 100 milligram per 100 milliliter, even if we have fasted overnight or eaten anything for several hours. And since all of our body and brain is designed to work better, when the blood sugar, fasting blood sugar is somewhere between 70 to 100, when the blood sugar stays above this, it affects our function. So that's why we call this condition diabetes. And then, as you mentioned, there are different types of diabetes depending on what has gone wrong or what is the cause or what is the condition or what is the severity of this condition. So a blood glucose level is maintained by primarily the action of two different types of mechanisms. One is the hormone. The hormones tell different cells to use glucose, and then the other side is all of our cells, particularly muscle, liver, etc., that use glucose. So now, unfortunately, there are some people who cannot make enough of this master hormone, which we call insulin, and as a result, even though their cells are hungry for glucose, they don't get the signal to pick up glucose. So we call it type 1 diabetes. Usually type 1 diabetic people know that they have diabetes because without insulin, their blood glucose level goes super high. In the US alone, nearly, we can say 1 in 200 people, adults, live with type 1 diabetes. And they have to pay attention to their glucose every single day, almost in every single hour. And then let's go to other forms of diabetes where the blood glucose level is slightly above 100, but below 225 milligram per deciliter or 100 ml. So we call them pre-diabetes. And in the US alone, there are nearly 40 adults out of 100 who are living with pre-diabetes. But unfortunately, many of them don't know that they are living with pre-diabetes. This is, you can say, mild form of diabetes, but this is a slippery slope. Many of them will eventually become diabetic. So what's wrong with them? Most likely, their insulin producing cells are still active. They're producing enough insulin, but the muscles are not listening to this signal. The organs are not listening, so the blood sugar level remains high. That comes to, then let's talk about the next form of diabetes where the blood sugar level, fasting blood sugar level goes above 125 milligram per 100 ml, and they still produce some insulin, but again, the organs are not responding to insulin signal. And we call them typically type 2 diabetics. There are nearly 15 out of 100 adults in the US who live with type 2 diabetes. Then there is another form of diabetes that affects mostly pregnant women. Maybe somewhere between 2 to 5 pregnancy out of 100 are affected by this very transient diabetes where the blood sugar level remains high. So let's focus only on pre-diabetes and type 2 diabetes because nearly 55 adults out of 100 in the US live with pre-diabetes or type 2 diabetes. The good news is lifestyle can help them maintain healthy blood sugar level sometimes with medication. And this is where the research on circadian rhythm is extremely relevant.
Awesome. So just to reiterate, this is not personal medical advice,
Yes.
and every person has different, and a lot of different doctors who specialize have different thresholds for what they consider someone to be blood sugar wise for type 2 versus pre-diabetes, what have you. These are all just kind of touch points that Dr. Panda has been looking at closely in terms of the link between circadian rhythm and, when I say types of diabetes, for the rest of this webinar purposes, I'm speaking specifically to prediabetes and type 2 diabetes. So
Yes.
no need to concern ourselves with gestational diabetes or type 1 diabetes, because those are completely different things under the same umbrella. So now that I've gotten that out of the way, one more definition for you so we can really get into this. What is time restricted eating and how does that play into circadian rhythm?
Yeah, so we know that circadian rhythms are very important because when our circadian rhythms are working fine, then our insulin production is optimum, our muscles and other organs can pick up glucose pretty well. Then the question is, what is the best way to maintain a healthy circadian rhythm? Most of us relate sleep and wakefulness to circadian rhythms, but research in the last mostly 15 years has also shown that when we eat has a huge impact on our circadian rhythm. And when I mean when we eat, it actually relates to eating consistently within a narrower window of time, somewhere between 8 to 12 hours, consistent time every single day. That's called time restricted eating. Since we are restricting time, not actually explicitly trying to restrict calories or quality of food, that's why the term is time restricted eating.
Awesome. Thank you, Dr. Panda. And I lied, one more last thing. What is the difference between time restricted eating and intermittent fasting?
Yeah, so the field of nutrition science has already established pretty well that the quality of nutrition and the quantity of nutrition are important. So that means by reducing calories, we can also improve our health. And we can reduce calorie intake by fasting once in a while. And that umbrella term, intermittent fasting, essentially relates to many forms of fasting. There are some forms of fasting where people fast 1 or 2 days in a week. And there are also some forms of fasting where people fast alternate days. And since the concept of time restricted eating essentially means that you eat within 8 to 10 hours or 12 hours, and consistently every day you fast for 12 to 16 hours, people also loosely combine all of these as intermittent fasting. In fact, in these days, when you say intermittent fasting, people mostly mean time restricted eating.
Right. It's definitely a buzzword right now, for sure. And again, just want to reiterate that time restricted eating isn't for everyone, and you should definitely consult your doctor before you take any of this and implement it for yourself. But now let's get into everything that you've spoken about so far and kind of summarize it together. So, what encouraged you to look into the connection between circadian rhythm and different types of diabetes or types of diabetes?
Yeah, so what was really intriguing in the field of circadian rhythm was we knew for a very long time that people who do shift work, they stay awake at night or work very late into the night, and they are more prone to diabetes. But people may say, well, they're exposed to different diet, different stress. So scientists did very simple experiment. They took healthy individuals and then reduced their sleep time or disrupted their circadian rhythm of eating and fasting. And within a week or two, these healthy individuals will have the telltale sign of pre-diabetes. Of course, we cannot make healthy people, diabetic just for experimental purpose, but that suggested that disrupting circadian rhythm can bring us closer to pre-diabetes and diabetes. Then the flip side of the same question is, can we fix circadian rhythm and prevent or reduce the severity of diabetes or pre-diabetes? And this is where my work comes in. And we started this work in mice, and we found that when mice eat within a set period of 8, 9, or 10 hours, sometimes up to 12 hours, even if they are eating unhealthy food that usually causes glucose insulin resistance or some forms of diabetes, they remain healthy. They can resist this nutritional challenge to become diabetic. And conversely, if we take mice that already have early signs of diabetes, if we put them under time-restricted eating, then they could reverse their pre-diabetes or diabetes. So those fundamental experimental work led to the idea that this might help humans who are at risk for diabetes.
Did you look at like a family history at all for any of the people that were involved in this? I guess it's hard, you can't for mice, but
Yeah.
is that a factor that you're considering?
What you're asking is whether this can address familial or genetic predisposition to diabetes. And of course, this research is very new, so we haven't connected genetics to diabetes or pre-diabetes and time-restricted eating. But in mice, there are many mouse genetic models, the mice that lack a gene that make them more prone to diabetes. And we have tested many of those mouse trends. And then what we find is many, not all, mice that have this genetic predisposition to being diabetic, they actually benefit by being on the time restricted eating schedule.
That makes sense because they are, helping stave off or
Yeah.
like push it, not reverse it right away, but they're limiting their intake there. So, how can kind of on the same path, how can time restricted eating affect someone's overall metabolism?
Yeah, so time restricted eating, how it affects metabolism, it's a very active area of research. Even in mice, we're just beginning to understand, but there are a few things that we know that are translating to humans. One is, I mentioned that how in pre-diabetes and diabetes, although the body produces enough insulin, our organs, our muscles, liver, etc., they don't pick up enough glucose. And what we find in mouse studies and also in human studies, that the body becomes more sensitive to glucose, to insulin, so that the cells can pick up more glucose. So that's one mechanism that we find where the one side of the equation where the organs are sensitive, becoming more sensitive to insulin. Then second, in human studies on time restricted eating, very controlled human studies from Courtney Peterson has shown that time restricted eating also improves beta cell function. So that means the beta cells are also more sensitized in a way that they produce they're more likely to produce an optimum amount of insulin for optimum duration to control to better regulate our blood glucose. People might think that when mice or humans are fasting for 14 to 16 hours, the metabolism may slow down, they may feel weak, they may not be able to exercise. But surprisingly, what we find is in mice, at least, mice that go through time restricted eating, they're as active or even more active in many cases than mice that don't do time restricted eating. And in human clinical studies, we have not seen in any of the research that has been published so far, more than 40 different papers published, reporting primary research, that in none of the studies people complained of low energy or feeling weaker. In fact, in many studies, what we find is people say they sleep much better, they're feeling more energetic throughout the day. So again, as I mentioned, this is an active area of research. I can only say about what we can find in mice, because in mice, for example, we can take the liver biopsy, the muscle tissue, etc. What we find is the liver is more efficient in handling glucose. It's more efficient in reducing fat production or depositing fat in liver. The muscles are also more efficient in using glucose and also producing a little bit of glucose when the mice go through fasting. So overall, it improves metabolism in every organ, beta cell in pancreas, liver, muscle, and also low inflammation in fat.
So to kind of summarize it a little bit in more layman's terms, if you will, the time that people are eating with time restricted eating is kind of allowing our bodies to make the most of what they do. So it's kind of like
Yeah.
making it a little
It
more
also, the
personal.
fasting time helps the body to repair, reset, and rejuvenate.
Exactly.
Because we always think that fasting is stressful for our body, but actually, fasting is the time when our body can repair. Just imagine, you cannot repair a highway when the cars are still running. You need to stop the traffic. So similarly, our body cannot repair itself when we are continuously eating.
Exactly. So, and anyone who takes supplemental insulin can, definitely knows that the timing of eating after taking insulin does play a factor. And again, not necessarily suggesting anyone who's on insulin therapy do specific fasting unless speaking with their doctor first. I'm basically a warning label today. So, to continue on with our conversation, um, let's get into your research a bit more. So how can diabetes be affected? You basically just answered this question.
Yeah.
So if you have anything else to add to it, let me know. Otherwise, I'll jump to my next one. But how can your research, how has it showed the circadian rhythm and time restricted eating has impacted glucose levels in the mice that you've researched?
Yeah, so as I mentioned, time restricted eating affects both sides of the equation. It improves the production of insulin, and also it improves the um, sensitivity of different cells to insulin. So in that way, people who have pre-diabetes, and as I mentioned, nearly 40 out of 100 adults in this country have pre-diabetes. And in certain states, for example, there was a report from California saying that 50% of Californian adults are now pre-diabetic. That means either if you are listening to this or someone you know already has pre-diabetes. And for them, it's a very powerful approach to um, implement time restricted eating to reduce the timing and maintain that 8 to 10 hours ideally of eating. What we're finding in human studies is when people eat within 8 to 10 hours, then they also inadvertently reduce their caloric intake. So they eat slightly less food. And we know that people with pre-diabetes or diabetes, they would benefit if they reduce their calories marginally by 10 to 20%. So they get that benefit. And then, as I mentioned, time restricted eating improves their beta cell function and all the organ function. And that all these work in tandem to improve glucose control.
Which then helps you prevent diabetes and helps gain better management.
Yeah.
I like to say management because it's really hard to control
Yeah.
things that your
Yeah.
body
Yeah.
does.
Yeah.
Not that you're wrong, but just for my fellow diabetics out there. So, like switching gears completely, let's talk about the role light plays in our circadian rhythm. So, specifically, your research has discussed blue light. Can you speak to this a bit more?
Yeah, so when we think about sleep, all of us we know that we cannot sleep in a brightly lit room. We need darkness, and the reason is light affects our brain function and our circadian clock. And for almost 70-75 years, starting from 1920, people did not know what type of light is most effective in resetting our circadian clock. And almost 20 years ago, three different labs, including mine, we discovered that a blue light sensitive protein called melanopsin, present in few thousand cells in our retina, can sense blue light and can reset our circadian clock, can reduce sleep, propensity to sleep. And in the daytime, it can actually work wonder because it reduces depression and increases alertness. Now the question is, how can we use that knowledge to our advantage? So, as I mentioned, during daytime, daylight is the best source of blue light. So it's better to have some exposure to light during the day. You don't have to stand under midday sun, even under a tree or sitting next to a window, not having direct sunlight gives you enough light for at least 30 minutes to have a healthy circadian rhythm in the brain, reduce depression, increase alertness. The reason why it relates to diabetes is many people with diabetes, they also experience sleep problem, and they also have, you can say, mild depression or depression. So having better light during daytime helps manage some aspect of it. In the evening, it's a very different story. We are designed to live, after evening, we're designed to be exposed to very little light, firelight or candlelight, which is not rich source of blue light. So as a result, what we can do is avoid bright light for 2 to 3 hours before bedtime. And when I say avoid bright light, for example, when you go to grocery store or pharmacy, usually the light is very bright, almost 1000 lux. That's 1000 times more brighter than a candlelight. What we need is less than 50 lux. So when you have a 40-watt bulb in a room, that gives you enough light to figure out what is there, what is where, but it doesn't disrupt your circadian rhythm too much. Similarly, keeping the brightness on your screen, your phone to the lowest level during night also helps. So in that way, by having some exposure to daylight, not sunlight, daylight during the day, and avoiding light for 2 to 3 hours, bright light for 2 to 3 hours before bedtime, helps us with better night's sleep. And that in turn also helps us to better manage our eating habit.
Awesome. And so, I'm sure something like limiting our screen time for a few hours up until bedtime can be helpful in and of itself. But and there are plenty of studies on that. But in terms of, like circadian rhythm and how the light then affects, insulin resistance and time restricted eating, can you talk a little bit about the whole connection between them?
Yeah, so when we have too much light at night, then we cannot sleep well. And when we have insufficient sleep, then our brain cannot function properly in the next day. And when I say brain cannot function properly, we know that if we didn't sleep well, we're a little bit cranky, we cannot think clearly. But that relates to our everyday life. But what is more important is in a day, we make more than 100, actually more than 200 different decisions about what to eat, how much to eat, when to eat, what combination to eat, when to stop eating. And those decisions also get confused. As a result, people have shown that when you sleep less, your brain craves for more food and more food from calorie dense diet, processed food, and all the food that we say junk food. So there is a, now you can link how having dim light in the evening helps you sleep better, and if you sleep better you can take better decision about your food, and you are not having that food craving, so that you can maintain all your food eating habits within this 8 to 10 hours, as well as make better decision about what you eat within those 8 to 10 hours. All of the things now work together to improve your blood glucose management.
Very cool. So I find it incredibly fascinating that your research shows that eating the same meals just at different times can lead to weight loss. Can you shine some light on that?
Well, I would say that we find in mice, and we can do those experiments and can find what is going on. So what we find is actually what happens is when we eat, since we eat a lot of food and we're not eating for next few hours, our body is designed to do two things. One, insulin actually signals our cells to soak up that glucose, but our glucose is not right away burnt. It has to be stored. And the best way to store glucose is to make glycogen, chains of glucose, or to convert that to fat and keep that fat when we're fasting. And if we keep on eating in every few hours, then our body doesn't get that long fasting signal, because when we are not eating, first our body will use the available glucose, then it will try to break down glycogen to make sugar, and then it will only after several hours of fasting it taps the fat store, and then it will slightly start to burn fat. So when at least in animals, what we see is when animals eat within 8 to 10 hours and then they're fasting, slowly they get rid of this, depleting their glycogen, then they turn on their fat burning mechanism. And we literally see that the brown fat, which is the healthier fat that literally burns fat to make energy, warms up our body, those brown fat become super activated. And then the liver also burns all the fat, so the liver doesn't store any fat. And then the fat cells in mice, they also begin to burn a little bit of fat and send it back to the liver to make what we call ketone body. And many people have heard about ketogenesis, ketone bodies. Mild ketogenesis is good for many of our performance. Of course, type 2 diabetics or type 1 diabetics, they have to tread a very fine path because too much ketone is also not good. Um, so we have to make it clear that all ketone or high level of ketone is not good. But this is how time restricted eating actually helps to turn on that fat burning signal in our body to burn those extra fat from the liver first and then from our fat cells.
So this weight loss can also have a kind of tandem effect where it can eventually potentially help reduce insulin sensitivity as well, right?
Yeah,
Or
it
insulin
will
resistance,
improve
I should say.
insulin sensitivity, reduce
Improve
resistance.
insulin sensitivity and reduce
Yeah.
insulin resistance, which kind of goes with the whole circle of how circadian rhythm, your sleep, your eating, your body making the most of it, what it produces, kind of go together for one better lifestyle. So I did want to clarify, we had one question. When we're talking about time restricted eating and intermittent fasting, are we considering, can you have water during that time, and medications? If you're taking any medications, obviously you should be taking your medications. But what, have you looked at that in mice at all?
Yeah, so our mice have ad libitum access to water. They can drink water anytime they want. And in human studies, we have also done studies where we have allowed people to drink, say, warm tea and a little bit of black coffee without sugar outside the eating window, and we find some good benefits. So, and as you mentioned from the beginning, people should consult with their doctor to see, because different people take different types of medications. Some have to be taken with food, some have to be taken without food. So it has to be personalized.
Right. And so if you can take medication without food, would taking that medication start over your clock? So
No, in many cases, it doesn't start over a clock.
I just wanted
Yeah.
to answer that question real quick. So I just wanted to, we're going to get into some more questions in a second, but I did have one more question for you. Was there a particular diet followed for the mice? I know we had discussed how it didn't matter what they ate to some extent, but what kind of diet led to these results? Or is it purely about circadian rhythm and timeframes in which you eat?
So when we started the experiments, we used the diet that most researchers use to make mice unhealthy and they gain weight and they become insulin resistant. So first we began with high fat, high sucrose diet, and even in the face of this very bad, nasty junk food diet, the mice could remain healthy. And then we have tried more healthy diet, moderately healthy diet, and in most cases, the mice stay healthy. What I must also emphasize in mice, when we combine time restricted eating with healthy diet, then mice actually gain a little bit of muscle mass and they have much better healthy state. So it's not only you don't have to just do time restricted eating. The message is if you can combine it with healthy diet, then the benefits are even much better.
And if someone is interested in applying this circadian rhythm idea in time restricted eating into their diabetes maintenance, how should they get started and what should they ask their doctor?
Well, the first thing everybody, whether you are healthy or not, should ask your doctor is your numbers. Know your numbers, because many doctors actually ignore to tell their patients that they have pre-diabetes. So know your numbers and make sure that your numbers are within healthy range. Then if you are within pre-diabetes, 100 to 125 milligram per 100 ml of blood, that's sugar level, most doctors are likely to tell you do some exercise, lose some weight. They usually don't recommend any medication. And that's good news, because then without medication, one can start with time restricted eating.
Just to clarify really quickly, we're talking about fasting glucose as your unit of measurement for
Yeah,
the
fasting
100
glucose.
fasting glucose. Another key measurement is your A1C,
Yeah,
which we don't have to get into that too
yeah,
quickly. And it's its own convoluted thing that
yeah,
has a lot of opinions from a lot of scientists about
yeah,
that. So not even sure I just spoke in English, but
yeah,
um, as far as like what to ask your doctor, definitely ask to see your numbers for fasting glucose is what you're saying,
yeah,
and potentially A1C.
yeah,
But in terms of implementing, again, another thing to ask would likely be, like if fasting is okay with your current medication regimen, things like
yeah,
that, right?
yeah, yeah. So that's definitely, you may not be diabetic, but if you're on other medications, you should bring that up with your doctor. And in my circadian diabetes score, what I mentioned is you can always begin with 12 hours time restricted eating, which is if you're sleeping for, say, if you're in bed for 8 hours, then 8 hours is your fasting anyways. And then if you, most people should avoid eating for 2 to 3 hours before going to bed, because when you're digesting food, it's hard to fall asleep. So that's 2 hours add up, that's 10 hours. And in the morning, usually for most of us, and it's also a healthy habit, to wait for at least an hour after waking up to have your first meal. That's almost 11 hours of fasting that everybody should be doing, and you just stretch it to 12 hours. And if you can adapt to it, then maybe you can talk to your doctor and make sure that your medications are optimum, and figure out what, when you do take your medication, and then maybe you can try to eat within 11 hours or 10 hours, and then see what you can manage with your lifestyle.
So
So
the clock, if you will, kind of comes down to we can include sleep in that time. We're not asking, you're not suggesting people fast for 12 hours during daylight hours necessarily
no, so
while you're awake.
maybe we can put all of this together, and if we share this graphic, then it makes a little bit easier. So for example, all sleep doctors and scientists agree that one should try to be in bed for 8 hours, try to go to bed at a consistent time, and be in bed for 8 hours, so that you can get 7 hours of sleep, which most adults need. After waking up, avoid food for at least 1 hour, because that's when our night hormones, melatonin, is going down, and day hormones, stress hormones, are going up. So our body is not ready, fully prepared to digest food. Then after eating breakfast, try to eat all of your food within 8, 10, or maximum 12 hours. But you should also plan your day so that your last meal is 2 to 3 hours before bedtime, because your stomach should at least partly digest your food so that you can fall asleep. And this is when your night hormone melatonin also begins to rise. And we didn't go into detail, the night hormone melatonin and food, they don't get together. And also avoid bright light 2 to 3 hours before bedtime. And bringing activity and daylight, we can also combine that, so that it's much better for people with pre-diabetes or diabetes to have afternoon outdoor activity, because again, circadian rhythm research is showing that afternoon physical activity is much better in controlling or managing blood glucose than the same activity in the morning. So if you're crunched for time, then maybe think about outdoor activity in the late afternoon.
That's so interesting. For me personally, again, as a type 1 diabetic, which differs from your research, I find that my blood sugars actually drop in the afternoon. So I try to avoid too much activity in the afternoon. But I could see how if someone had higher, like elevated glucose, without adding insulin to their routine, how making sure that activity, which as most diabetics know, lowers your glucose levels, can kind of put you at a good place for sleep, if you
Yeah.
will, for absorbing your nighttime meal. Thank you so much, Dr. Panda. We have a few questions that we want to get into. First up is from the listener right now. So, is type 2 diabetes related to dementia? And can you explain the impact of dietary timing and circadian rhythm on any other age-related conditions or illnesses?
Yeah, so there is an emerging idea that type 2 diabetes might increase our risk for dementia. And there is so let's step back and acknowledge that diabetes is not one disease. When our blood sugar level goes up, then since our different parts of our body and even our brain is actually designed to perform well when our fasting blood glucose is below 100 by 100 milligram per 100 milliliter. When it goes up, then it can affect different body parts in different way in different people. So that's why we say diabetes doesn't come alone, it brings its sinister friends. Many type 2
Uplifting thoughts here, Dr. Panda.
Sorry?
I said these are some uplifting thoughts here.
Well, we have to acknowledge that
Yeah.
diabetes is increase in blood sugar, but the way it affects our body, it's almost like corrodes. It's like putting your car.
It can snowball, if you will.
Yeah.
There are different conditions that can develop because your body is operating at a higher level of glucose, which can
Stress.
affect anything from your eyes to
Kidney,
nerves. Yeah.
Yeah, and even your stomach and numbness. And we know that high blood glucose can kill some neurons so that people feel numb in their feet. So similarly, we assume, but it's very difficult to make that connection between high blood sugar and risk for future dementia, because the hypothesis is building. And again, people who get dementia, they also have many other pre-existing conditions. But we can make this connection that since our body is designed to be optimally functioning with moderate glucose, when the glucose level goes up, then other things can happen.
So another question from the audience is, and feel free to let me know if you don't feel like we can answer this, but how does alcohol affect glucose levels? It seems to drive, this is again from the audience member, it seems to drive them down in the immediate term. And there's evidence that moderate drinking can have a positive effect on glucose levels. Is this true? I can speak from a type 1 perspective and using a continuous glucose monitor and seeing those trends, but let's hear from you for a greater.
I guess you should speak, because you always wear a CGM, and then you can speak from your experience.
But I mean, yes, again, I'd like to reiterate, I have type 1 diabetes. My body does not produce insulin, my beta cells. It's a whole story for another time. But personally, and again, with type 2 diabetes, the thought process is people are still producing a bit of insulin. So it's a little harder to say that drinking will affect any one person a specific way, because there's so many factors, right? There's what you're drinking. Is it like a frozen pina colada, which has carbs in it, extra carbs, or is it a shot of vodka, like, spirits, straight up? So personally, and again, I am not a medical professional, so Dr. Panda, feel free to jump in at any point. Personally, I do tend to drop for up to 24 hours after drinking alcohol. I see the effects on my blood sugar. I do tend to rise in, within the first hour, and then it's a journey to keep my blood sugar above a certain threshold where I'm comfortable for the preceding at least 12 to 24 hours after that. But again, that's as a type 1 diabetic wearing a continuous glucose monitor and seeing those trends. Can you speak to this at all, Dr. Panda?
Well, I guess, as you mentioned, the type of alcohol matters a huge extent, because, as you said, a shot of vodka versus margarita or something else is very different. Second, we don't just drink alcohol and stop there. We have chips, we have dips, we have other stuff that goes with it. We have to be mindful about that, because we think that moderate alcohol drinking is okay, but at the same time, we also eat and indulge in other stuff. And then the third, so that's why it's a very difficult question to answer. And mouse studies don't necessarily, in this regard, may not translate very well to humans because mice are not actually designed to drink alcohol, or they may also have a different way to metabolize alcohol. The third one that you brought up, very important point, is continuous glucose monitor. So that's why you might hear from even other type 1 diabetics, their response to alcohol might be very different. So the CGM gives us a very powerful way to see for ourselves what kind of food at what time, and in combination with what kind of exercise or previous few hours of history affects our blood glucose. And I must strongly urge, if anyone can can convince your endocrinologist to prescribe you a continuous glucose monitor, please try to do that for at least 2 weeks, and don't bug your endocrinologist every time your blood glucose goes up, because
Yeah,
that's
we're
what they
definitely,
hate about, because they don't want to prescribe because people will bug them in every 3 hours.
it's a
But I
very
guess that's
powerful tool
yeah.
though. And I think that there are some instances where pre-diabetics can even get access to CGMs, at least for short periods of time, to see how their bodies are reacting to what they eat, and
Yeah.
how their insulin levels are going along with that.
Yeah.
So moral of that story is consult your doctor, but also alcohol should, I think you will never find a doctor that will say alcohol should be used to lower your blood sugar,
Yeah.
for so many reasons. But hey, we've all been there, so you're not alone. But another question that's changing gears a little bit here. So as you're reducing from, let's talk about, let's say you're sleeping for 8 hours and you want to have time restricted eating for 12 hours. Should you be adding on those 4 hours at night or in the morning to your time restricted eating?
Yes, there is not much rigorous study on that. What we do in our study, we ask people to self-select a 10-hour window. And what we are typically finding is people try to wait 2 to 3 hours in the morning after waking up to have their breakfast. And then they also have 2 to 3 hours before bedtime to finish their dinner. By the same time, there are also other studies, other clinical trials where people have been advised to start their eating somewhere around 11 to 12 noon, and then go till 8, 9, or 10 at night. And that also seems to work. But what we suggest is try to figure out which 10-hour or 12-hour window best suits your lifestyle, so that you can stick to it for many, many months or years. Because what you need to adopt is a lifestyle that you can adopt every single day. It's not a course of weight loss for 3 months and then the effect will stay with you.
So you can kind of customize it to whatever makes
Yeah.
it long
And we
lasting.
haven't seen any significant difference between morning time restricted eating or late time restricted eating
Gotcha.
when it comes to blood glucose control
Okay.
management.
Awesome. So final question here for you. Does the age of your diabetes diagnosis, and this also might kind of affect the type of diabetes, but specifically let's talk about pre-diabetes and type 2 diabetes. Does the age of that diagnosis impact how effective dietary timing would be? So is there a certain age? Is it ever too late to try this, or is it too early if you're, a teenager and already are pre-diabetic?
I used to say that anyone from the age of 10 to 100 can try to eat within 12 hours. Nothing, no big harm will happen. So, and in our mouse studies and animal studies, we have seen older mice and older animals can adapt and they get many benefits. In our human studies, we have also seen people with 10 years living with diabetes or pre-diabetes. They can start and they will see some results, benefits within 3 to 6 months. And if they can sustain with the habit, then the benefits also remain. I must also, as I said, diabetes doesn't come alone. It comes with its sinister friends. And one of the sinister friends is hypertension. Many type 2 diabetics also have high blood pressure. and they also have high cholesterol. And what we find is when people try time-restricted eating, whether or not you are taking medication to lower your blood pressure or blood cholesterol, of course, in consultation with your doctor, you can figure that out. Time-restricted eating seems to reduce both blood pressure and LDL cholesterol. In our studies on people with metabolic syndrome, that means those people already had pre-diabetes or diabetes and also had cholesterol and high blood pressure. So in that way, by adopting time restricted eating, you're more likely to better manage either blood glucose or many of the other conditions that exist with high blood glucose.
So we really need to wrap up, but I wanted to get one final question in here. Does napping or any type of daytime sleeping affect your circadian rhythm and affect the outcome of this whole research?
No, napping, actually, we are designed to nap. We have, scientists have shown that humans are actually designed to have a sleep pressure. Our sleep pressure increases right after lunchtime. So we're designed to be more active in the morning around twilight times so that we can stay away from midday sun and take a restful nap for an hour or so. Don't nap for 3 to 4 hours, then you cannot sleep at night. And that again disrupts your circadian rhythm.
So you heard it here, folks. You can use Dr. Panda as your excuse for your daytime nap. I will definitely be trying that. Thank you so much. Really, this is all the questions that we have time for. I will say, not to completely circle back to our full conversation, but we had a few questions talking about if you consider coffee creamer or like sugar-free coffee creamer or just plain milk in your coffee to be breaking that intermittent fasting. I believe you recommended black coffee, but without going into too much detail, can you give us an answer on that?
I mean, I will get into a little bit of detail.
Okay, deal.
Okay, when I say 100 milligram per 100 milliliter of blood sugar should be, if you now drain all of my blood, you'll find 5 liters of blood in me. So that means if you squeeze all the sugar out of my blood, then you'll find 5 grams of sugar. So that's 1 teaspoon of sugar. And if I have 1 extra gram of sugar in my blood sugar level will be 120 milligram per 100 ml. And if I have 2 grams of sugar, half a teaspoon, it will rise to 140 milligram per 100
Now you're just
milligram.
showing off. But
So that means even a half teaspoon of sugar
it impacts your blood
without help from insulin is likely to increase your blood glucose. So now we can do the math.
Sadly, black coffee,
Black coffee.
no added creamer, even if it is sugar-free. Unfortunately, all these things do have carbohydrates, which do impact our blood glucose over time.
Yeah.
Thank you so much, Dr. Panda. I encourage everyone to learn more in Dr. Panda's latest book. I believe we have it up on the screen. It's available to purchase from your preferred book vendor. So definitely get that. And it gets into more detail about exercise and time-restricted eating, and really all the questions you could have are answered there. So what's coming up next in our Live Better Longer series? It's going to return in the fall. So be sure to be on the lookout for that. And thank you so much, Dr. Panda. Thanks everyone for your support, and be sure to help continue supporting AFAR so we can do more free, fun webinars like this.
Thank you. Have a perfect circadian day.
I hope to. I hope you do as well. Thank you, everyone, and enjoy the rest of your day and get a nap in. Thanks.